26 degrees 34 minutes north, 56 degrees 15 minutes east, the Strait of Hormuz. It is 3:06 p.m. local time. The air temperature is 112 degrees Fahrenheit, but on the flight deck of the USS Jack H. Lucas, the heat index is pushing 130. The air here doesn't just sit, it presses. It is a physical weight, thick with the smell of evaporated salt, ozone, and the faint, sweet sick scent of unburnt hydrocarbons drifting from the commercial shipping lanes 3 miles to the north. The visibility is compromised. A thick, brown thermal haze distorts the horizon line, merging the gray-green water of the Persian Gulf with the bleached white sky. To the naked eye, a small fishing dhow at 2 miles looks like a floating mirage. But the Jack H. Lucas is not looking with naked eyes. She is listening. She is feeling. She is the first of her kind, a Flight 3 Arleigh Burke-class destroyer, a $2 billion sovereign territory of the United States, and she is currently vibrating with the low-frequency hum of 4 General Electric LM-2530 gas turbine engines. These engines are not merely power plants. They are the beating heart of a predator. Derived from the TF-39 turbofans used on the C-5 Galaxy heavy transport aircraft, each turbine is a masterpiece of aerothermal engineering. Inside the casing, a 16-stage axial flow compressor is spinning at thousands of revolutions per minute, compressing the hot, humid Gulf air by a ratio of 18 to 1. This compressed air is mixed with marine diesel fuel in an annular combustor, ignited and expanded through a 2-stage high-pressure turbine. The resulting energy, over 100,000 shaft horsepower combined, is transferred through a complex system of reduction gears, turning the twin controllable pitch propellers at the stern. This power generation is critical not just for propulsion, but to feed the beast that lives within the ship's superstructure. The Lucas requires electricity on a scale that previous warships could not comprehend. It needs this power because, at 3:06 p.m., the world is about to witness a masterclass in naval devastation. The silence of the bridge is broken not by a shout, but by a digital chirp from the Combat Information Center. A red icon flickers onto the large screen display. Then another, then 12 more. The threat is not theoretical, it is here. Let's rewind. To understand why 12 Iranian fast attack craft are currently sprinting at 45 knots toward the most advanced warship on the planet, we have to look away from the water and look at the ledger. This kinetic event did not begin with a throttle push. It began with a currency collapse. 7 minutes of context are required to understand the desperation of the adversary. The Iranian economy by late 2025 had effectively ceased to function as a global entity. Years of sanctions, internal mismanagement, and a catastrophic drop in oil revenue had turned the rial into paper confetti. Inflation was not rising, it was galloping, obliterating the savings of the middle class in Tehran and Isfahan. The regime was cornered. A cornered regime does not seek diplomatic off-ramps. It seeks external validation through conflict. It needs a victory, or at the very least, a spectacle, to distract a populace that is hungry and angry. The propaganda fed to the crews of the Islamic Revolutionary Guard Corps Navy, the IRGCN, was specific, potent, and technically flawed. They were told that the Great Satan relies on satellites that can be jammed. They were told that the American destroyers are clumsy, blind giants, unable to track targets smaller than a sedan. They were told that a swarm of 20-foot speedboats laden with high explosives and rocket-propelled grenades could overwhelm the sensory overload of a Western warship. They were trained in the doctrine of Ashura, a philosophy of martyrdom and asymmetry. They believed that their sheer number would saturate the American fire control loops. They believed that if they got close enough, under the radar horizon, they would be invisible until the first rocket impacted the hull. This was the narrative sold to young men in Bandar Abbas. Speed defeats size. Spirit defeats technology. But looking at the tactical situation map inside the American CIC, it is clear that this narrative failed to account for the laws of physics, as applied by the Raytheon Corporation. The USS Jack H. Lucas was not in this sector by accident. It was conducting a freedom of navigation operation explicitly designed to challenge Iran's excessive maritime claims. The mission profile was aggressive: transit the strait, hold the center line, and demonstrate sea control. Sea control is a sterile term for a violent capability. It means that within a radius of 200 nautical miles, nothing moves, nothing flies, and nothing floats without the permission of the Combat Information Center. The Iranians saw this presence as a provocation. They saw the hazy silhouette of the destroyer and saw a target. They launched the swarm from a hidden cove on Keshem Island at 2:58 p.m., timing their run to intercept the destroyer as it passed the narrowest choke point. They made 3 catastrophic mistakes. Mistake number 1 was a fundamental underestimation of the electromagnetic spectrum. They assumed the Jack H. Lucas was just another destroyer. They did not know they were sprinting toward the first operational deployment of the AN/SPY-6 V.1 air and missile defense radar. We must pause here. You cannot understand the violence that is about to occur without understanding the SPY-6. This is not a rotating radar dish like you see in World War II movies. This is a phased array system, a collection of 4 massive octagonal faces bolted to the ship's superstructure. Each face is composed of thousands of individual radar modular assemblies, or RMAs. These are 2-foot by 2-foot cubes, self-contained radar units that can be stacked like building blocks. In previous generations, ships used the SPY-1 radar, which relied on a central transmitter tube called a traveling wave tube. If that tube went down, the radar went down. The SPY-6 is different. It uses gallium nitride, GaN, technology. Gallium nitride is a semiconductor material that is infinitely more efficient than the silicon or gallium arsenide used in older systems. It allows power amplifiers to run at higher voltages and temperatures, pumping out 30 times more radar energy than the legacy SPY-1 system. 30 times the sensitivity, 30 times the detection range. What does this mean in practice? It means the SPY-6 does not just see a boat. It sees the rotation of the radar antenna on the boat's mast. It sees the sea spray kicked up by the bow wake. It can detect a periscope at ranges that defy the curvature of the Earth due to atmospheric ducting. The cost of developing and fielding the SPY-6 program sits in the billions, with each shipset costing upwards of $500 million. That price tag buys you integrated air and missile defense. The radar performs volume search, tracking, and missile guidance simultaneously. It creates a 360-degree hemisphere of awareness that processes terabytes of data per second. When the Iranian swarm left Keshem Island, they thought they were hiding in the clutter, the radar noise created by waves and commercial traffic. To the SPY-6, the clutter was mathematically deleted. The gallium nitride modules pulsed indiscriminate energy through the haze, painting the fiberglass hulls of the attack boats with absolute clarity. The computer system didn't just see them, it categorized them, calculated their velocity vectors, and assigned a threat priority score to each one before the Iranian captains had even engaged their throttles. Mistake number 2 was a failure of strategic doctrine. The Iranian swarm tactic relies on saturation. The idea is simple math. If the American ship has 2 guns, sending 20 boats ensures that 18 will get through. This doctrine ignores the layered defense concept of the U.S. Navy. The Jack H. Lucas is not a single shooter. It is a node in a kill web. The moment the SPY-6 detected the inbound bogies, the data was not just displayed on the ship. It was data linked via Link 16 and the Cooperative Engagement Capability, CEC, to every other asset in the theater. A P-8 Poseidon maritime patrol aircraft, loitering at 20,000 feet 30 miles away, instantly received the tracks. An overhead MQ-4C Triton drone slewed its electro-optical sensors to the coordinates provided by the destroyer. The Iranian doctrine assumed a duel. They walked into a firing squad. They failed to account for the vertical integration of the United States Navy. They were playing checkers on a board where the U.S. was playing 3-dimensional chess with live ammunition. The saturation attack works against a passive victim. Against an integrated killing machine, saturation just provides a target-rich environment. Mistake number 3 was psychological. They miscalculated the temperament of the man in the chair. Commander David Grave Daughtry did not rise through the ranks by being a diplomat. He spent his early career as a weapons officer, a WEPS, obsessed with the geometry of interception. He is a man who calculates risk in percentages and engagement windows. The Iranian psychological profile of a U.S. commander suggests a fear of escalation, a hesitancy to fire first for fear of political blowback. Daughtry operates under different standing rules of engagement. His interpretative matrix for hostile intent is calibrated to 0 margin for error. When the swarm turned hard toward his ship, breaking from the commercial lane, Daughtry didn't ask for permission from Fifth Fleet. He didn't hesitate. He looked at the range counter, 8 miles and closing at 45 knots, and he looked at the specific maneuver. They were in a pincer formation, attempting to split his fire. To Daughtry, this wasn't a political incident, it was a physics problem. Velocity times mass equals kinetic energy. His job was to reduce the kinetic energy of the inbound threats to 0 before they touched his hull. The bridge of the Jack H. Lucas went deadly quiet. The only sound was the hum of the air conditioning and the rhythmic clipped reports from the tactical action officer. Tracks 1001 through 1012 designated hostile, inbound high speed, range 7 miles, weapons tight is lifted, batteries released. Now begins the kinetic exchange. This is the pulse. The heartbeat of the ship shifts from monitoring to killing. At 3:18 p.m., the first layer of the defense activates. It is not a missile. It is the Mark 45 Mod 4 5-inch lightweight gun sitting on the forecastle. This weapon is often dismissed in the age of hypersonics, but that is a fatal error. The Mark 45 is a fully automated naval artillery system. It is not aimed by a sailor looking through a sight. It is enslaved to the Aegis combat system. The gun mount weighs roughly 25 tons. It is fed by a complex hydraulic magazine deep within the ship's hull, capable of holding hundreds of rounds. Let's spend 3 minutes on the Mark 45 because it is about to do heavy lifting. The barrel is 62 calibers long, meaning the length of the barrel is 62 times the bore diameter of 5 inches. This extended length allows the propellant gases to expand fully behind the projectile, accelerating it to a muzzle velocity of 2,700 feet per second, that is Mach 2.4. The shell leaves the barrel faster than a rifle bullet. The specific ammunition selected by the computer for this engagement is the High Explosive Variable Time, HEVT, fragmentation shell. This is old-school lethality upgraded for the digital age. The variable time fuse is actually a miniature Doppler radar transceiver in the nose of the bullet. As the shell spins at thousands of RPM, it emits a radio signal. When that signal reflects off a target, a fast boat, a drone, a mast, the fuse detects the closing distance. It is programmed to detonate not on impact, but slightly before or directly above the target. The cost of a single Mark 45 round is roughly $2,000 to $3,000, pocket change in modern warfare. But the effect is catastrophic. The shell contains a bursting charge of composition A3 explosive. When it detonates, the steel casing shatters into thousands of jagged supersonic razor blades. Against a steel-hulled warship, it creates surface damage. Against a fiberglass fast attack boat, it turns the air into a shredder. The gun cycles at 20 rounds per minute. Boom. 3 seconds, boom, 3 seconds, boom. At 3:19 p.m., the Mark 45 opens up. The sound is a physical slam against the chest of anyone on deck, a dry, cracking thunderclap that rolls across the water. The first round is a ranging shot in theory, but with the SBY-6 providing fire control data, there is no ranging. There is only hitting. The shell arcs over the 6 miles of water, flight time roughly 12 seconds. The Iranian lead boat, a Tundar-class missile craft, never sees it coming. The HEVT fuse senses the boat's mass structure. It detonates 15 feet above the deck. The airburst shreds the radar antenna, the bridge crew, and the exposed rocket launchers in a millisecond. The boat doesn't sink immediately. It loses way, turning into a burning, drifting hulk. The swarm does not stop. They have been trained for this. They accelerate. 11 boats remain. Range 5 miles. Commander Daughtry shifts the engagement logic. The gun is effective, but it is one tube against 11 targets. It is time for the missiles. He authorizes the use of the AGM-114L Longbow Hellfire missiles mounted on the surface-to-surface missile module of the ship, but the Lucas has something better. It has the RIM-174 Standard Missile 6, the SM-6. Usually an anti-air weapon, the SM-6 has a secondary surface mode. It is a terrifying misuse of air defense technology. The SM-6 costs over $4 million per unit. It is 21 feet long, weighs 3,300 pounds, and is powered by a dual-thrust solid rocket motor. It hits speeds of Mach 3.5. Using an SM-6 against a speedboat is like using a sledgehammer to kill a mosquito. It is expensive, overkill, and absolutely final. The missile launches vertically from the Mark 41 VLS cells on the foredeck. The launch is violent, a pillar of white smoke and fire that scorches the blast deflectors. The missile tips over, accelerating instantly. It does not fly a ballistic arc, it flies a depressed trajectory, skimming the waves. The active radar seeker in the nose of the SM-6, derived from the AMRAAM air-to-air missile, locks onto the lead boat of the Southern Pincer Group. The impact is kinetic. The missile still has unburnt rocket fuel. It hits the small craft at over 2,000 miles per hour. There is no explosion necessary. The sheer kinetic energy of a 1.5-ton object hitting a 40-ton boat vaporizes the target. The boat disintegrates into a cloud of fiberglass dust and atomized fuel. 2 down. The remaining 9 boats are now within 3 miles. They are closing the distance fast. This is the danger zone. This is where the RPGs become viable. The swarm splits again, trying to flank the Lucas C. Daughtry orders hard rudder right, bringing the ship's broadside to bear, unmasking the aft weapon systems. It is time for the close-in defense. It is time for the phalanx. The phalanx CIWS, close-in weapon system, is the goalkeeper of the U.S. Navy. It sits on the superstructure, a white domed R2-D2 looking robot that commands a 20mm M61 Vulcan Gatling gun. Let's go deep on the phalanx. It is a self-contained killing unit. It has its own search radar and its own track radar. It doesn't need the ship's main computer, it thinks for itself. The radar operates in the Q-band, allowing it to track the incoming projectiles, specifically the rockets the Iranians are preparing to fire, and the outgoing bullets simultaneously. It creates a closed-loop fire control solution. It watches its own stream of fire and adjusts it in real time to walk the rounds onto the target. The gun is a 6-barreled rotary cannon, electrically fired, hydraulically driven. It spins up instantly to a rate of fire of 4,500 rounds per minute. That is 75 rounds every second. The ammunition is critical. The Phalanx shoots Mark 244 Mod 0 armor-piercing discarding Sabot APDS rounds. These are not lead bullets. They are subcaliber penetrators made of tungsten alloy, one of the densest metals on Earth. The tungsten penetrator is encased in a plastic sabot that falls away when the round leaves the muzzle. The penetrator flies at 3,600 feet per second. When it hits a target, it doesn't mushroom. It pierces. It goes through engine blocks, through hulls, through high explosives. At 3:24 p.m., the remaining swarm boats fire a salvo of unguided rockets. The air fills with smoke trails. The Phalanx spins up. The sound is not a machine gun. It is a buzzsaw, a continuous tearing that vibrates the fillings of everyone on the bridge. The tungsten stream is a solid line of white tracers. The CIWS engages the rockets first. The radar tracks the heat signatures. The tungsten rounds intersect the rockets in midair, detonating warheads, chopping fins. Then the Phalanx lowers its aim. It walks the stream of tungsten into the nearest attack boat. The effect is hydromolecular. The water around the boat erupts in geysers. The boat itself is stitched from bow to stern. The tungsten rounds punch through the outboard engines, igniting the fuel tanks. The boat cartwheels, consumed in a fireball. The Phalanx slews to the next target in under a second. Brrrr! Another fireball. The Iranians are now inside the keep-out zone. They are desperate. They are firing heavy machine guns, 12.7 millimeter rounds pinging uselessly off the Lucas's armored steel hull. They are trying to ram, but the Lucas is nimble. The controllable pitch propellers reverse pitch on the port side, push full ahead on the starboard. The massive destroyer pivots on a dime, creating a wall of wash that swamps a 20-foot boat. At 3:30 p.m., the 25mm Mark 38 Mod 3 machine gun systems, located on the port and starboard bridge wings, join the fight. These are chain guns, stabilized by gyroscopes, aimed by sailors using optical directors with thermal imaging. They are surgical. The gunners are targeting the engines of the retreating boats. Thump, 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 thump. The 25mm high-explosive incendiary rounds dismantle the outboard motors of the fleeing craft. By 3:39 p.m., the radar scope is clear of hostile tracks. The water is littered with burning debris, oil slicks, and the smoking remnants of the IRGCN swarm. 12 boats entered the engagement zone. 0 left it. The Jack H. Lucas slows to 5 knots. The damage control teams report in. All systems nominal. No hull breaches. No casualties. The aftermath is a scoreboard of asymmetry. The U.S. Navy expended roughly 45-inch shells, 2 standard missiles, and 4,000 rounds of 20mm tungsten. The total cost of the engagement for the U.S. taxpayer was roughly $10 million. The cost for Iran was their entire localized naval capability in the Strait. The silent message broadcast to the region is deafening. The world watched a coordinated, multi-layered saturation attack, the very thing that was supposed to doom the U.S. Navy, get dismantled in under 40 minutes. The Iranians threw their best asymmetric punch, and the Jack H. Lucas barely broke a sweat. Control was restored not through negotiation, but through the application of overwhelming, integrated, and precise kinetic violence. The strait is open, the oil will flow, and the Arleigh Burke turns back to its patrol course, its radar faces scanning the horizon, ready to do it all over again. This is the reality of naval supremacy. It is not about fair fights. It is about ensuring the fight is over before the enemy realizes they have lost. The heat index is still 130, the haze is still thick, but the threat board is empty. To fully appreciate the deep dive requirement, we must examine the logistic and electronic warfare components that enabled this victory, specifically the SLQ-32 V7 and the Nulka decoy system, which played invisible but critical roles during those 39 minutes. While the kinetic weapons were the executioners, the SLQ-32 V7 SEWIP Block 3 was the shield bearer. This system is the primary electronic warfare suite of the destroyer. It doesn't shoot bullets, it shoots electrons. The Slick 32, as sailors call it, listens to the radio frequency environment. During the approach of the Iranian swarm, the boats were communicating via high-frequency radios and using commercial marine radars for navigation. The SLQ-32 detected these emissions long before the SPY-6 radar had a visual track. The Block 3 upgrade is significant because it introduces active electronic attack. In the past, the system could only listen and launch decoys. The new system can jam. It uses active electronically scanned array (AESA) technology, similar to the SPY-6, to focus beams of high-powered jamming energy at specific targets. During the engagement, as the Iranian boats tried to coordinate their pincer movement, their radios were flooded with white noise generated by the Lucas. They were shouting orders into a void. Their navigation radars were fed false returns, showing ghost ships and static walls, confusing their approach vectors. And when the rockets were fired, the Lucas deployed the Mark 53 Nulka decoy launching system. The Nulka is an active, hovering rocket decoy. It is launched from a tube and flies away from the ship. Once airborne, it hovers in midair and emits a massive radar cross-section, electronically screaming, "I am a ship." To the simple seeker heads of the Iranian rockets, the Nulka looked like a juicy aircraft carrier. The rockets veered away from the Lucas, seduced by the brighter electronic target, and exploded harmlessly in the empty air behind the ship. This is the hidden layer of the 39-minute war. The combination of hard kill, bullets, missiles, and soft kill, jamming decoys, creates a defensive onion that is nearly impossible to peel. The Iranians tried to peel it with a knife. They found a diamond core. The final scorecard: U.S. losses 0. Ammunition expenditure 2% of magazine capacity. Iranian losses: 12 fast attack craft sunk, estimated 60-80 casualties, total loss of tactical surprise. The Jack H. Lucas sails on. The hum of the turbines continues. 3:45 p.m. Control restored.